Why don't we just start off? Why don't we just start off with what's your name and what you do, what your practice is, and yeah, how you got into 3D printing.
Well, my name is Paul Macy, and I have been doing CAD for many years, for 35 years or so,
Wow.
and pretty much have been practicing for almost 30 and using CAD. So for me, the next step of using CAD to mill a socket mold and make it in traditional methods, the next step was obviously 3D printing, which is something I invested in uh, 6 or 7 years ago. So I've been heavily involved in sort of creating a process that works for our company,
Yeah.
since then. So,
Nice. Wow. 30 years in CAD. So in the very beginning? What was it like? What were the tools that you were using 30 years ago?
well, I was an engineer before this. So I was working as an engineer. I have a master's in mechanical engineering and sort of worked in the aerospace industry on helicopters and stuff. And that's where my
Wow.
background comes from before um, I made a career change and got into orthotics and prosthetics. So for me, it was just kind of a natural because I was already doing this type of stuff. So when I
Yeah.
got into this field, I basically started out with CAD with ShapeMaker, which is an old CAD program, that's been around
Really.
forever, and that's what I used for years to modify molds with. So that program, and that's still available. It's a great program, so you can modify BKs, AKs, and that kind of thing.
Yeah.
So I used that for many years, and then I've used other CAD systems, but
A lot of it was milling before 3D printing came in, right? Like, yeah, the applications.
yeah, that was the only application was milling of foam molds,
Yeah.
which is still done very successfully.
Yeah.
there,
Yeah. For
there are
sure.
many companies, yeah, that mill their molds, and now in recent years, the past whatever 5-10 years, are milling L-shaped molds, which are AFOs. So basically, it still works extremely well, and companies have very successful protocols and processes in place where they're milling out foam molds and then traditionally fabricating
Off of those.
sockets and braces and whatever. It's done all over the world, I think. So
Oh yeah.
you know, so nothing against that, but the concept for me was just sort of I just wanted to get into the next sort of step of that, which is the actual printing of the device. So
Yeah. And so, what made you decide to go into the MJF side over FDM? Was it a transition from FDM to MJF, or did you go straight to the higher end machine?
um, so started out just printing check sockets, um, and uh, and then just wanted to not just print the check socket, but print the more definitive, the thing that's going out the door that's being delivered. That part of the prosthesis. So started out with FDM, did some work with another company that was doing FDM sockets. They were printing them early on, and for me, I knew that just a powder based system just made more sense to me from an engineering perspective, and still does, simply because of the concept of the material being isotropic, where the z axis is just as strong as x and y. So with FDM, where you're printing up, it's just not going to be as strong, in my opinion. So
Yeah.
um, that was really the concept of just sort of moving over to MJF. So I
Fantastic.
pretty much just did my own experimenting.
Yeah. Well, and you also talked to me once about, you got into some sort of ISO certification or got some testing done to make sure that what you were practicing was valid. Can you talk a bit about that?
Well, yeah, I mean, we did some basic testing to utilize the ISO standard that exists now, which is obviously not really for sockets. It's more for probably feet and knees and whatever components. But it's the best we have, and it's the only thing we have. So we use that and did some testing, and others have done testing. And more recently, HP has put out an excellent
Yes, they
uh,
have.
whole testing protocol where three sockets were tested and really did extremely well relative to
Yeah, I remember you
carbon
pointed me to
carbon
those.
dating.
I read that documentation. That was really cool. Like they took it to breaking point, and it was, and then which
Yeah,
was
the bottom line is they were close, and both in the fatigue and the static, load tests,
yeah,
they're basically very very similar. And if you consider the fact that much of what we make, obviously is probably over designed because we don't want something to break. I think it's been shown that it's valid to use an MJF socket clearly, plenty strong enough if it's designed properly,
yes.
with a big emphasis on if.
If yeah,
So,
and having your standards in place and repetition. We started working together last year, and we got together over color workflows. You had asked me about some of the stuff I had done.
mhm.
What got you into color, and like in terms of how it affected the patient output or patient care? Like, what were you trying to achieve initially, and how have you leveraged that in the present here?
Yeah, I mean, basically, in 3D printing, I started out, we couldn't do color because I hadn't investigated yet. We were just doing the larger HP printers, which only print, the black color,
Mm-hmm.
basically, was all we were doing. And so I just wanted to get into color, and knew that that was sort of the next step. What I was doing, in black and white, or black, I should say, and we still are doing, is embossing images on it. So we would emboss on the front surface, say, a picture of something, or a phrase, or I mean,
Yeah.
we did one yesterday. The patient just simply wanted his initials on the front of the leg. That's
Oh
all he
wow.
wanted. He just wanted initials, AC. That was it. So we just embossed that, so we could emboss on there. But obviously, the next step was to do color, um, and so that's where that evolution sort of came from.
Nice. What what limitations have you seen in the workflow for color, or no, even just the color outputs? Because I know the spectrum of color is very limited sometimes. If you get into, I believe, reds are very harsh to pull off. Blues are great, or blacks are not very deep. Like, what's your experience on that?
Yeah, I mean, it's not perfect. It's not a piece of artwork. It certainly isn't going to print color in a super glossy, perfect
Yeah,
way,
Coca-Cola
like
red or bust. It's like
yeah,
comes out
like
brown.
yeah. It's just not that sophisticated. And the color printer that we use from HP, the 580 machine, HP has stopped making anyway. So they're, I think, obviously going to be evolving into the next
Yeah,
printer.
I hope so. I hope there's a big brother coming, and it wasn't end of life because of just lack of niche, or like lack of opportunity in the niche market for it.
I I would be astounded if there wasn't some work going on that, for whatever companies, that the companies aren't releasing that yet. But I can't imagine that there's not going to be a
Yeah.
color printer to
Well, in
replace
my
that.
in my mind, there is a bit of a disconnect because HP is an industrial production printer, and there are 3D printers out there that do color really, really well, and those are for high fidelity prototypes or for your stop motion feature films, right? And creating a bunch of heads and assemblies like the Stratasys J850 or the Mimaki printer from Japan. Those are really fantastic color printers, right? But they're not production ready parts at all, right? And so there's
Mhm.
to require nice colors in production, or to require production performance from little color parts, sometimes is like just not justified depending on who you're dealing with. So to me, that was the only you know disconnect maybe in my head. um
Well, hopefully, I mean, hopefully they will be, but currently we're limited, really, at least in our application and protocols. That's the only color printer we use, and it is limited. I mean, it has a smaller build volume, so you cannot get large
AKs or something.
AK frames in the thing or whatever. You can get good size sockets in there though, but not anything really large.
Yeah.
So that's certainly a limitation. The limitations of the color, like we said, it's not going to print perfectly, red to red, blue to blue, but it looks really nice, and the patient knows what it is, and that's
Yeah.
what's important.
Yeah.
So,
So I wrote a piece recently on the emotional recovery of patients using product device design, and how the emotional recovery of an amputee can really be affected when considered through product design. So the glue that binds the user to a product, like an Apple iPhone, or the utensils in, or the appliances in your kitchen. Like there's a language there that really binds people of a materialist society to the products they use. There's an intuition. There's actually an identity extension to there. As an industrial designer, I loved studying that, and that was my bread and butter. And one of the reasons I got into prosthetics was because there was a very real human to product interface and some sort of emotional extension of identity. It's like if you take away someone's leg, it really is taking a part of who they are away, even though it's a product. Um, so, how has the ability for you to offer color and custom bespoke legs like this? How have you seen that affect sort of the emotional recovery of some of your patients?
Yeah, well, I mean, it helps. Anything helps. I mean, we're making a brace or a prosthetic leg for somebody, and so any way that they can sort of own it a little bit more, I think helps it fit better, which makes no clinical sense, but it makes all kinds of emotional sense for them. So,
Yeah.
um, hey, if they can own it and then just enjoy a little bit more of what they have to wear if they want to walk,
Mm-hmm.
it only helps. And it's something that, we've known in the field for 50 years or whatever. I mean, we've been laminating color sockets forever, for decades.
Yeah.
Um, and so this is an extension of that. And, and probably a little bit more of an extension because of the way we can personalize the socket. So, if a patient has a picture of anything, their dog or their child or their favorite car, motorcycle, whatever it is, we can gather that picture or pictures, images, and
Mm-hmm.
create that on the socket for them, and then it's really customized for them.
Yeah.
And I think that's got a lot of value. So
Yeah, absolutely. And there's products coming up, like Enable for kids, where they have these Iron Man hands that are just so out there, or unique fairings that have a cover that's very much from Star Wars or something on top of it. Like to me, it's a great shift. Instead of trying to hide the fact that it's a prosthetic leg with skin tones and foam covers, it's actually like a huge celebration of the situation, as opposed to trying to hide it. um, I love that about the field and where it's actually going.
yeah.
Well, I thank you for taking the time and talking about this. What
Sure.
would you, as a closing thought, what's the one thing that you would recommend to someone who's looking to get into color do to start their journey? Or like, can they come to you? Do you have a website or a service that you offer for people who are interested in getting a color device?
No, we're just they should go to you. We're a smaller, regional orthotic and prosthetic company, just doing day-to-day O&P, taking care of patients. So we just have in-house protocols that we've developed, with your help, Arthur. So people could certainly, you know, ask you to help with the color. I did not have a color process because it is confusing. There's a bunch of steps to it.
Yeah.
I'm extremely good at designing on CAD and coming up with the sockets and all that stuff. It's what we do. But the process of actually then getting a color image to wrap around the socket properly and all of that was beyond me, and I came to you for that. So I'm sure
Nice.
there's other ways to do it, but like I said, we're a smaller regional company, and anything we do, it needs to be efficient, not break the bank as far as getting into an investment to be able to do it, and something that's pretty clean and quick. So that's what we just established now. But
Nice.
it takes some time. There's a learning curve.
Oh
None of this
yeah.
stuff happens like right away. You totally have to tinker with it and be willing to do that. If you're not willing to spend some time, don't even bother.